Hello children, welcome to a session of Definite Integrals. My name Kavitha is Nair, Faculty of Silver Hills Public School, KOZHIKODE, Handling Mathematics, Class 12. In the previous session, we discussed definite integrals in which we applied substitution, partial fraction by parts. Today, in the session, we will discuss definite integrals and their properties. The properties are very important. We will use them in doing problems so that the integration will be simpler. Let us see the properties. Integral a to b fx dx is equal to integral a to b ft dt. The limits are same, only the variable is changed. This can be applied. For example, integral sin x dx from same limit is same as integral sin t dt on the same limits. Second, a to b fx dx is equal to minus of b to a. Here a to b, it is reversed b to a fx dx. In particular, if we are integrating from a to a, we are not changing the limits from a to a itself, then the value of the integrand will become 0. Then, property number 3, a to b fx dx is split into two integrands, a to c fx dx and integral c to b fx dx, where c lies between a and b. We can split this into more than 2. When the problem comes, we shall discuss about it. This result is useful in doing modulus functions. Now, integral a to b fx dx is equal to integral a to b f of a plus b, sum of the limit minus x dx. Its a particular form is this one. When a takes the value 0, b takes the value a, the change accordingly, here 0, a became 0, b became a, f of a minus x dx. This is also a very important result which we apply in doing the sums. Then comes integral 0 to 2a. 2a fx dx is equal to 0 to a fx dx plus 0 to a f of 2a minus x dx. When this 2a minus x dx is becoming equal to f of x, this part will become f of x. So, integral 0 to a fx dx, 0 to a fx dx makes twice 0 to a fx dx. And one more thing, when this f of 2a minus x is becoming equal to minus of fx, so this part will be negative of this one, both will get balanced, you will get the value of the integrand as 0. This result also is important. Now comes the last result. Integral minus a to a f of x dx is equal to twice 0 to a f of x dx, provided the function is an even function. What do you mean by an even function? In the place of x, when you substitute minus x, if you are getting the function without change, then it is called the even function. And the value of the integrand will become 0 if it is an odd function. What do you mean by an odd function? In the place of x, if you replace by minus x, the function will become negative of the function. When we do the sums, we will make it more clear and understand properly. Now, let us do one sum. I equal to integral 0 to pi x sin x by 1 plus cos square x dx. The derivative of cos x is minus sin x, but you can see an extra x there. How to remove it and do the integration? Let us apply a property and do it. We are going to apply the property integral 0 to a fx dx is same as integral 0 to a f of a minus x dx. Let us see. I can also be written as I equal to integral 0 to pi, where you see x we are going to apply pi minus x. Pi minus x into sine pi minus x dx whole divided by 1 plus cos square pi minus x. Now, what is pi minus x? Where it lies? 180 minus x means it is lying in quadrant number 2. In quadrant 2, sine is positive. Sin pi minus x will be sin x, numerator. Denominator, cos of pi minus x. In second quadrant, cos pi minus x will become minus cos x, but it is square here. So, it will become positive. So, let us write equal to 0 to pi minus x sin x dx whole divided by 1 plus cos square x. Now, let us split this into two integrands equal to 0 to pi into sin x dx divided by 1 plus cos square x, then comes minus integral 0 to pi x sin x dx divided by 1 plus cos square x. Left side was our I, and you can see here I the same integrand, isn't it? So, this is our I. Actually, it is minus I when it comes to this side, I plus I. I plus I equal to, we can take the constant pi outside, pi into integral 0 to pi sin x dx divided by 1 plus cos square x. Now, let us put there cos x equal to t. So, 2i equal to pi into cos x equal to t. Derivative of cos x minus sin x equal to dt divided by dx. So, sin x dx will be equal to minus dt. Now, let us change the limits. When we substitute it, the limit also will change. When x takes the value 0, x equal to 0, t will become cos 0, which is 1. Then, when x takes the value pi, the upper limit, cos will be pi, t equal to cos of pi minus 1, minus 1. This limits also let us apply. So, pi into integral instead of 0, 1, instead of pi minus 1, sin x dx minus dt divided by 1 plus t square equal to minus pi into, what is dt by 1 plus t square? It is tan inverse t. So, tan inverse of t under the limits 1 to minus 1. So, we can apply minus pi into tan inverse of minus 1 minus tan inverse of 1. 2i equal to, now minus pi, tan inverse of minus 1 is minus pi by 4. And again 1 minus should be there. pi by 4, tan inverse 1 is pi by 4. So, how much it became? 2i equal to minus pi into minus 2 pi by 4. 2i equal to minus pi into minus 2 pi by 4 equal to 2 and 4 get cut here 2 minus minus plus pi into pi square divided by 2. This was the value of 2i. So, our integrand I will be equal to pi square divided by 4. This is our final answer. Coming to another question of same type. We are going to apply the same property here. You can see one x as previous in the numerator. We are going to apply integral 0 to a fx dx is equal to 0 to a f of a minus x dx. That property again we are applying in the same question. So, let us write I equal to integral 0 to pi, where we see x we will write pi minus x. Pi minus x tan of pi minus x divided by sec pi minus x plus tan pi minus x dx equal to integral 0 to pi minus x tan pi minus x. In the second quadrant, tan is negative. So, we will get minus tan x divided by sec pi minus x, again comes minus sec x plus minus tan x as said before dx. Now, we can see a negative common, isn't it? One minus is here. Taking minus from both of this, minus. Both the minus from numerator and denominator will get balanced. We will get I equal to integral 0 to pi minus x tan x divided by sec x plus tan x dx. Now, let us split it into two integrands. I equal to integral 0 to pi tan x dx divided by sec x plus tan x. Then comes the minus x minus integral 0 to pi x tan x dx divided by sec x plus tan x. Now, again as in the previous question, we can see the second part is I itself, that is this part is your question I itself. Let us take I to this side, that is minus I. So, I plus I makes 2I equal to, let us take the constant from that side, pi into integral 0 to pi tan x dx divided by sec x plus tan x. Now, let us make this tan and sec in terms of sine and cos to make the simplification more easier. Equal to pi into 0 to pi sine x by cos x whole divided by 1 by cos x plus sin x by cos x into dx. Now, we can see numerator cos x is there, denominator when you take LCM then also you can see a cos x. So, 2i equal to pi into 0 to pi sin x dx divided by 1 plus sin x. Now, we can see 2i equal to pi into 0 to pi sin x divided by 1 plus sin x dx. Let us take the conjugate of the denominator and multiply, continue in the next step. 2i equal to pi into integral 0 to pi sin x dx divided by 1 plus sin x. I copy the same step, equal to pi into 0 to pi sin x into 1 minus sin x dx divided by 1 plus sin x into 1 minus sin x equal to pi into 0 to pi sin, I am multiplying inside, sin x minus sin square x divided by a plus b into a minus b, a square minus b square, 1 minus sin square x. What is 1 minus sin square x? Cos square x. Cos square x dx. Now, let us divide each of the numerator by cos square x and simplify. 2i equal to pi into 0 to pi sin x by cos square x. Sin x by cos x, tan x, 1 by cos x is sec x. So, sec x tan x minus sin square x by cos square x, tan square x. Tan square x dx. The integrand became like this. We know integral sec x tan x is sec x. But to make the integration simpler here, let us convert tan in terms of sec. Next line. 2i equal to pi into integral 0 to pi sec x tan x minus sec square x minus 1 and a dx equal to, let us open the bracket, pi into 0 to pi sec x tan x minus sec square x minus minus plus 1 dx. This is our 2i. Now we can integrate everything. Let us integrate pi into integral sec x tan x is sec x. Sec x minus integral sec square x is tan x. Tan x and integral 1 is x. Under the limits 0 and pi. Now let us give the upper limit and lower limit respectively. 2i equal to pi into sec pi minus tan pi plus pi, upper limit finished, minus sec 0 minus tan 0 plus 0. 2i equal to pi into sec pi is minus 1, tan pi 0, then comes plus pi, minus sec 0 1, tan 0 0, again 0. Now, inside the bracket what comes? Pi minus 1 minus 1, pi minus 2. 2i equal to pi into pi minus 2. So, our I became pi by 2 into pi minus 2. It was really a little bit long answer, but practice makes it easier. Another question in which we are going to apply the property again. 0 to a fx dx is same as 0 to a f of a minus x dx. Here the limits are 0 to pi by 2. Previous both questions it was 0 to pi. Now let us see. I equal to integral 0 to pi by 2 f of a minus x sine raised to 4 pi by 2 minus x divided by sine raised to 4 pi by 2 minus x plus cos raised to 4 pi by 2 minus x dx. We applied the property. So, both i's are equal. Again equal to 0 to pi by 2. What is sine 90 minus theta? It is cos theta. So, it will become cos raised to 4x divided by sine 90 minus theta, cos theta. Cos raised to 4x plus cos 90 minus theta is sin theta. Sine raised to 4x dx. Now, let us give this as equation number 1, our question, and after applying property, what we got as equation number 2. Both are equal to our I. Look that the denominator of both equation 1 and 2, they are same. If we add the equation sin raised to 4x plus cos raised to 4x, the numerator also become same to that of the denominator. So, let us add 1 plus 2 gives 2i equal to integral 0 to pi by 2. The numerator sin raised to 4x plus cos raised to 4x divided by the common denominator sin raised to 4x plus cos raised to 4x dx. Now, the integrand is 1. So, equal to 0 to pi by 2 dx. Both got cancelled. So, 2i equal to x upon the limits 0 pi by 2. Giving upper limit pi by 2 minus 0, 2i becomes pi by 2, or value of I will become pi divided by 4. So, applying the property, look how the integration become easier. A similar question as previous. This is our I question. Again we can apply the same property. Integral 0 to a fx dx is same as 0 to a f of a minus x dx. So, also I equal to 0 to pi by 2 root of sine pi by 2 minus x divided by root of sine pi by 2 minus x plus root of cos pi by 2 minus x dx equal to 0 to pi by 2 sine 90 minus theta, as I said before, cos theta. So, root of cos x divided by root of cos x, cos 90 minus theta, sin theta, root of sin x dx. Let us give equation number 2 and the question as number 1. Same way as the previous question, we can see the denominators are same, the order is changed, that's all. Root sin x here plus root cos x will come when you add. So, let us add the equations. Equation 1 plus 2 gives 2i equal to integral 0 to pi by 2 root of sin x plus root of cos x whole divided by root of sin x plus root of cos x. The numerator and denominator both are same. So, it will get balanced. Integral 0 to pi by 2 dx. So, 2i will be equal to integral dx is x upon the limits 0 and pi by 2. Giving upper limit and lower limit respectively, pi by 2 minus 0. That was our 2i. So, I will become pi by 4. So, simpler. Now, we are going to apply another one property which we saw in the previous slide. Minus a to a integral. Minus 1 to 1. Fx dx was equal to twice 0 to a fx dx if the function is an even function and equal to 0 if it is an odd function. Let us see what is our function, even or odd. Take this as f of x. F of x equal to sin raised to 5x cos raised to 4x. Let us give minus x. F of minus x equal to sin raised to 5 minus x cos raised to 4 minus x. Sin minus theta is minus sin theta. So, minus sin x raised to 5 and cos of minus theta is positive cos theta. So, cos x raised to 4. This will become minus to the power odd power negative again. Negative sin raised to 5x cos raised to 4x. What is this part? This is our fx. So, minus of fx. Therefore, f of x is an odd function. Therefore, the value of our integrand will become 0. Very simple, but you can do it simpler way only if you can understand the function is odd or even. A similar question, look the limits minus a to a. Let us see what is fx and f of minus x. F of x equal to sin raised to 7x. Let us replace x by minus x. F of minus x will be sin raised to 7 minus x equal to minus sin x to the power 7. It is an odd power. So, negative sin raised to 7x, which is minus of f of x. F of x is sin raised to 7x. F of minus x is minus sin raised to 7x. So, it became minus of fx, which indicates that the function is an odd function. Therefore, f of x is an odd function. So, this is a part of the answer itself. So, the value of our integrand became 0. Let us see a modulus function. Integral minus 1 to 2 modulus of x cube minus x dx. This part is our f of x. The closed interval minus 1 to 2 I am going to write it as a union of certain intervals. Please look, minus 1 to 0, union 0 to 1, union 1 to 2. I split it into 3 parts. Now, let us see the nature of the function fx in each of these intervals. N minus 1, 0, our function is x cube minus x. Let us give a value lying between this to x. Example, x equal to minus half. So, fx will become equal to minus 1 by 2 whole cube minus 1 by 2 minus 1 by 8 minus plus 1 by 2 equal to 8 LCM minus 1 plus 4, which will be 3 by 8 positive. We have to get the positive or negative, that's all. In the next interval, 0 to 1, f of x is x cube minus x. Let us take a value lying between this, x equal to 1 by 2. So, f of x will become equal to 1 by 2 whole cube minus 1 by 2 equal to 1 by 8 minus 1 by 2 equal to 8, 1 minus 4, which will become minus 3 by 8 less than 0, it is negative. And again in the last one, 1 to 2. F of x is same as x cube minus x. Let us take a value in between, 1 and a half, x equal to 1 and a half. That means it is 3 by 2. So, f of x will be changing to 3 by 2 whole cube minus 3 by 2, which will be 3 into 3 into 3, 27. 27 by 8 minus 3 by 2, LCM 8, 27 minus 4 into 3, 12. Now comes 15 by 8 positive. So, we saw in the 3 intervals, first one the function takes the nature of positive, here it is negative, then positive. So, let us change the modulus sign and give the signs accordingly. So, I will be equal to our integral minus 1 to 2 modulus of x cube minus x dx we can write as integral minus 1 to 0, it was positive, x cube minus x dx. Then second one from 0 to 1, it was negative, x cube minus x. And the third case from 1 to 2, x cube minus x dx, it was positive. Now let us integrate and give the values accordingly. Equal to x raised to 4 by 4 minus x square by 2 upon the limits minus 1 0 minus x raised to 4 by 4 minus x square by 2 on the limit 0 to 1 plus x raised to 4 by 4 minus x square by 2 on the limits 1 to 2. We integrated. Now let us give the upper limit minus lower limit equal to, when you give 0, here it becomes 0, here it becomes 0. So, 0 minus Now I am going to give minus 1. Minus 1 raised to 4 is 1. 1 by 4 minus 1 square, again positive 1. 1 by 2. This part is over. Then minus, when we give 1, 1 by 4 minus 1 by 2, upper limit is over, minus, when you give lower limit, it will become 0 completely. Now let us give the last one. 2 raised to 4 by 4 minus 2 square by 2, we give upper limit, minus 1 by 4 minus 1 by 2, we give lower limits also. Now let us simplify. Here comes, let us take it outside, minus 1 by 4 plus 1 by 2. Minus 1 by 4 plus 1 by 2. Second, minus 1 by 4 plus 1 by 2. Then 2 raised to 4, 16. 16 by 4 is 4 plus 4 minus 2 square, 4 by 2, 2. Now comes minus 1 by 4 minus plus 1 by 2 plus 1 by 2 equal to, how many minus 1 by 4s are there? 1, 2, 3. 3 times minus 1 by 4. Then 1 by 2s, 1 by 2, 1 by 2, 1 by 2. 3 times 1 by 2. Now 4 minus 2, 2. So we can write I equal to minus 3 by 4 plus 3 by 2 plus 2. What is the LCM? 4 is the LCM. Minus 3 plus 3 into 2, 6 plus 4 into 2 comes 8. Minus 3 plus 6, positive 3. 3 plus 8, 11. So I equal to 11 divided by 4. Final answer. Again a modulus function. 0 to 4 mod x minus 1 dx. Let us split 0 to 4 into 0 to 1, 1 to 2, 2 to 3 and 3 to 4. So 0 to 4, 0, 1, union 1 to 2, union 2 to 3, union 3 to 4. Now let us see the nature of our f of x in each place. So 0 to 1. Our fx is x minus 1. So let us give x equal to 1 by 2. So what will our fx become? Fx will change to 1 by 2 minus 1 equal to minus 1 by 2 less than 0, negative. Then comes in the interval 1 to 2. Let us give x equal to 1.5, that is 3 by 2. So our fx will change to 3 by 2 minus 1. We are substituting in x minus 1. X minus 1. So 3 by 2 minus 1 means 3 minus 2 by 2, which is 1 by 2, positive. Second interval it is positive. In interval 2 to 3, let us take x equal to 2.5. 2.5 means how much? 5 by 2. So our fx will change to how? 5 by 2 minus 1, which will become LCM 2, 5 minus 2, which is 3 by 2, which is positive. Again, now the last interval 3 to 4. X, let us give the value 3.5 equal to 7 by 2. So, let us see, fx will be changing to 7 by 2 minus 1, 7 minus 2 divided by 2 equal to 5 by 2 positive. So, you got in the first interval it is negative, second interval positive, third interval positive and fourth interval also positive. So, let us change the integrand and write I equal to integral 0 to 4 modulus x minus 1 dx will be equal to integral 0 to 1 minus x minus 1 dx. First interval it is negative plus integral 1 to 2 x minus 1 dx plus integral 2 to 3 also x minus 1 dx plus integral 3 to 4 also it is x minus 1 dx. 3 of them are positive. So, we can integrate from 1 to 4 directly because its nature is not changing, equal to minus 0 to 1 x minus 1 dx plus, let us combine this, integral 1 to 4 x minus 1 dx. Okay, now let us integrate. 1 negative outside, x square by 2 minus x under the limits 0 and 1, then comes plus x square by 2 minus x under the limits 1 to 4. This was our integrand I equal to negative 1 by 2 minus 1, I gave the upper limit, minus 0. Now, let us do the second one. 4 square divided by 2 minus 4, we gave upper limit, minus 1 by 2 minus 1, we gave the lower limit also, equal to, what is 1 by 2 minus 1? Minus 1 by 2. That minus 1 by 2 and this minus positive 1 by 2, correct? Plus 4 square 16 by 2, 8, minus 4, again 1 by 2 minus 1 is minus 1 by 2. That minus and this minus positive 1 by 2, equal to half plus half 1 plus 8 minus 4, 4. So, value of the integrand became 5. Now, in this question, we are going to apply another property. You can see the limit pi by 6, which is 30 degree, pi by 3, which is 60 degree. Some of them is 90 degree. I gave a hint, some of them is 90 degree. Now, let us simplify this integrand and write I equal to integral pi by 6 to pi by 3 dx divided by 1 plus, instead of tan x, let us write sin x by cos x, root of sin x divided by cos x. Now, let us take the LCM throughout. So, what will come? Pi by 6 to pi by 3, the cos x, root cos x coming in the denominator will go up, root of cos x dx divided by, here comes root of cos x plus root of sin x. Okay, this is our I. Let me give this as equation number 1. Here we are going to apply the property integral a to b fx dx is equal to integral a to b f of a plus b minus x dx. Let us see. I equal to integral a to b root of a plus b minus x cos of pi by 6 plus pi by 3 minus x dx divided by same way root of cos of pi by 6 plus pi by 3 minus x plus root of sin pi by 6 plus pi by 3 minus x equal to integral pi by 6 to pi by 3. What is cos 90 minus x? It is sin x. So, numerator comes root of sin x dx divided by root of sin x plus what is sin 90 minus x? It is cos x. Root of cos x. Let us give this as equation number 2. Now we got I as equation number 1 here and equation number 2. Is there any similarity in the denominator? Yes, they are same. So, if we add the numerator sin x plus root cos x, that will become similar to that of the denominator. So, let us add the equations 1 and 2. Equation 1 plus 2 gives I plus I equal to integral pi by 6 to pi by 3 root of cos x plus root of sin x divided by denominator also the order is different, no problem, root of cos x plus root of sin x dx. Now what is the integrand? It will get cancelled. So you will get 2i equal to integral pi by 6 to pi by 3 dx. Now let us see. 2i equal to, I am copying the same step, pi by 6 to pi by 3 dx equal to integral dx is x. X on the limits pi by 6, pi by 3. Now let us give the upper limit and lower limit respectively. Pi by 3 minus pi by 6. LCM 6. 2 pi minus pi. So, 2i equal to pi by 6. So, I will be equal to pi divided by 12. That is the answer. Now, let us see another question. In the same question also we are going to apply the property which we did previously. Integral 0 to a fx dx is equal to integral 0 to a f of a minus x dx. Let us see. I is also equal to 0 to pi by 2 logarithm of sine pi by 2 minus x dx equal to 0 to pi by 2 logarithm of sine 90 minus x cos x dx. This is also our I. Now, let us give the question as number 1, this as number 2. Let us add 1 and 2. 1 plus 2 gives I plus I, 2I equal to integral 0 to pi by 2 logarithm of sin x plus logarithm of cos x into dx. Now, here we can see log sin x plus log cos x. We can combine using the property of logarithm and write log sin x cos x. If there was log 2 sin x cos x, we could have written log sin 2x. So, we are going to add log 2 and subtract log 2 in this step. 2I equal to integral 0 to pi by 2 logarithm of sin x plus logarithm of cos x plus log 2 to balance minus log 2 dx. Now, let us combine the first three. These three, log a plus log b plus log c, log abc. 2I equal to integral 0 to pi by 2 logarithm of sin x cos x 2, that is 2 sin x cos x, which is sin 2x. So, let us write in this line logarithm of sin 2x remaining minus log 2 minus log 2 dx. Now, this part we have to integrate. That part is easy because log 2 is a constant. Let us make it into 0 to pi by 2 log sin 2x minus log 2 constant 0 to pi by 2 dx. 2I equal to 0 to pi by 2 log sin 2x dx minus log 2 integral dx is x pi by 2 0, correct. 2I equal to 0 to pi by 2 log sin 2x dx minus log 2 into pi by 2 minus 0. So, here you are getting the line 2I equal to 0 to pi by 2 log sin 2x dx minus pi by 2 log 2. Now, let us copy it to the next line and continue. 2I equal to integral 0 to pi by 2 log sin 2x dx minus pi by 2 log 2. Let us give 2x equal to t. 2x equal to t, differentiating with respect to x, 2 equal to dt divided by dx, or dx will be equal to dt divided by 2. Now, let us see the change in the limits. When x takes the value 0, t takes the value 2 into 0, 0. When x takes the value pi by 2, t equal to 2 into pi by 2, which is equal to pi. Now, let us apply all these things in the integrand. Equal to integral limits 0 to pi logarithm of sine 2x is t, dx is dt divided by 2, that I am writing by 2 here, minus pi by 2 log 2. Now, we are going to apply a property here. Integral 0 to 2a fx dx is equal to twice 0 to a fx dx if f of 2a minus x is equal to f of x. What is 2a here? Pi. And 2a minus x means pi minus x. Sin pi minus x is sin x itself. So, sin pi minus t will be sin t. So, let us apply the property. Twice 0 to a. This is 2a. So, a will be pi by 2 log sin pi minus t is sin t. So, log sin t dt minus pi by 2 log 2. Now, 2 and 2 will get cancelled. You will get 2i equal to 0 to pi by 2. Now, I am going to change the variable t to x. Log sin x dx minus pi by 2 log 2. Is it possible to change from t to x? Yes, the limits are not changed, only sin t dt changed to sin x dx, which is correct as per our property number 1. Now, let us see what is this 0 to pi by 2 log sin x dx. Look, is it the question itself? Yes, it is our I. So, right here, this is our I. 2i equal to I minus pi by 2 log 2. 2i minus I, you get I equal to minus pi by 2 log 2. A very important question. This comes as a part of another one question in the miscellaneous side. Now, today we saw lot of properties and their applications. Some questions are very easy, some are little bit lengthy, but practice makes it more easier. With this, the definite part is also over. Now, again there is one more session in which we will deal with miscellaneous questions of the chapter throughout. Till then, take care. Thank you.